Chapter 6, Chemical Composition. You've probably heard that it's not good to eat too much sodium, right? People with high blood pressure have to watch their sodium intake. And yet we do need some sodium or we would die because our bodies rely on sodium for a lot of different things. So it's an important dietary mineral. It's involved in regulation of body fluids. But eating too much can cause your blood pressure to go high, and that's not good. Well, how much is too much? The FDA recommends that you consume no more than 2.4 grams, that's a lot, 2,400 milligrams of sodium per day. So how are we ingesting sodium? I told you earlier, sodium, the element, is a metal that reacts violently with water. So that's probably not what we're eating, right? We're eating sodium in the form of sodium chloride, table salt. Well, sodium chloride has a mass that is larger than just the mass of the sodium in it because there's also chlorine in there. So how much sodium chloride, how much salt could you eat and still be within this guideline set by the FDA? 2.4 grams of sodium chloride would be a lot of salt, but that wouldn't be even close to the limit of sodium, okay? So the chemical composition for sodium chloride is given by its formula, NaCl. For every one sodium ion, there's one chloride ion. But sodium ions and chloride ions do not have the same mass. We can see on the periodic table that a sodium atom weighs 22.99 atomic mass units, and a chlorine atom weighs 35.45 atomic mass units. The fact that one's gained an electron and one's lost an electron doesn't really matter because the number of the mass of the electron is so tiny in comparison. So we can't get a very clear picture of the relative masses just from the formula. So what we need to do is we need to calculate the amount of the constituent element, the one that we're interested in a particular amount of compound. And this happens in all kinds of different situations. So here's a picture of a mine. They're mining iron. Well, you don't find just chunks of pure iron in the ground. You find it in the form of compounds, iron ore. And so a company wants to know, well, how much iron ore do I need to gather up to get a certain amount of iron out of it? And we do that by looking at the chemical formula along with that formula mass or the atomic masses that we've been learning about. In chlorofluorocarbons like Freon 12, we want to know how much chlorine is in a given amount of that because it's the chlorine that's causing the problem with the ozone.